Hello and welcome. Today we are going to quickly look at 4 different types of glassware used in a lab, where we have beakers, Erlenmeyer flasks, also known as conical flasks, graduated cylinders, and volumetric flasks. Alright, we'll start with beakers. Beakers are just a general container for liquids. There's a handy little spout here for pouring liquids. They are not for measuring volume. I can take a container with some liquid and I can very easily pour that liquid without spilling because I have a little pour spout. If I then wanted to know exactly how much volume I had just poured into this container, I don't have enough information. These lines for volumes written on here in milliliters, those are just to help you get a good estimate. We do not use beakers for measuring volume. Erlenmeyer flasks are also good general containers for liquids, and much like beakers, they are not for measuring volumes, because as you can see here, we don't have any precision with our volume increments on the side. Those numbers are just there for your convenience, not for actually making measurements. The nice thing about Erlenmeyer flasks is this conical shape makes it easy to mix. It's hard to do with my left hand. I can mix the solution by swirling it around, and I don't have to worry about it spilling out of the top. And now we're on to, finally, something we can use for measuring volumes. Graduated cylinders. If you check out here, it's a cylinder. And it has graduations or marks with lots of precision for measuring different volumes. This one here is a 10 milliliter graduated cylinder. And so if you are measuring a volume in this graduated cylinder, I'm going to pour some liquid in there. You don't have to hit the 10 milliliter mark because we've got these extra little gradations in here that we can use. We have a line for 8 milliliters, this line for 9 milliliters, which is not marked, and then a line for 10 milliliters. To judge where your line is, we have to make a little bit of an estimation. You can see that the surface is uneven. That's because the surface tension of the water has a tendency to climb up the sides of the container. And the spot that we want to go by is the lowest point, which is in the center of this curved surface. We call a meniscus. This high point near the 9.8 line is a little higher than if I come over here and I look at different angles. I can see that it's a little bit lower than that 9.8, but it's definitely higher than the 9.6 line. And so I would say this is maybe about 9.7 milliliters. And that might be the most precision I could possibly get with this particular piece of glassware. You always can add a little extra precision by guessing how far your meniscus is between those two lines. On this 50 milliliter graduated cylinder, we actually get a little extra precision. The meniscus is a little bit below the 34 line. And so it's somewhere between 33 and 34, closer to 34. I would say that this is about 33.8 milliliters. And that's a judgment call. Somebody else might say 33.7 or 33.9. That's why that last sig fig is uncertain. Last but not least, we have volumetric flasks. The goal with volumetric flask is usually to make a solution, a new solution, where you have a well-known final volume and you have additional ingredients that you put in here before filling up the volume to its fullest capacity. Like, let's say I put 1 milliliter of blue food coloring in there, and I know that I want to then have a final volume of 100 mils. That's why I chose a 100 milliliter volumetric flask. Now I can just add water, which is my solvent here, in order to create a 100 milliliter solution that had 1 milliliter of blue food coloring in it as an ingredient. I'm going to fill it up almost to the line, but you see that I haven't filled it all the way. Here's the line. And here's the water level right now. I want to make sure that the solution is mixed well before I bring it up to that final line, because when you mix solutes and solvents together, the density can change. And then I add a little extra solvent. This is just a little bit more water to get it up to that line. Let's zoom in here. Oh, I'm right on the line now. I think that's pretty good. Maybe I need one more drop, huh? What do you think? And now I'm finished making my solution of blue food coloring. Yay!